Good afternoon, everyone. We're Team 1. I'm Sarhad, and my teammates are Garmihar, Naveed, and Zeng. I introduce you to our project, Doodle to Gucci. Our project is to take input of doodles of clothing and convert them to a real-life render. This would be helpful for designers to quickly design ideas for clothing. Now, I'll be talking about data we used for training. We used an open source dataset called Deep Fashion 2, which contains about 490,000 images. For our training, we are only interested in trousers, tops, and skirts. The dataset is structured with an image and a corresponding annotation that contains the source category, the bounding box, the segmentation, and the visibility. We remove objects with less visibility. Our data collection step consists of two phases to filter and process the images. In our filtering process, we check if the photo is professional, part of the category we need, and is not blurry. In this example over here, the t-shirt is non-blurry and is moved to the next step, but the pant is discarded. In the processing of images, we isolate the area of interest by removing the background using the annotations and perform edge detection. After our data cleaning process, a raw image on the left is processed to isolate the background. The edge-detected version is a sample doodle for training. Notice that the top is ignored because of the hands blocking it. We found out that a lot of our sample data had bad posture or objects covering the clothing. To remove bad samples, we removed images with more than two segmentation polygons. Now I'll be passing on to Zhang to talk about our model.
Thanks, Sarhad. Let's start with the baseline model that we used to check the feasibility of our project and evaluate the performance of our model, a simple autoencoder. We overfit the autoencoder to a set of real images after we tested it using doodles as input, and the results are as you see here. The resulting images were bland and don't capture any information related to texture patterns, but they do maintain shape, which is a good start. Moving on to our primary model. We use a conditional GAN, which instead of random noise for input, cGANs take additional input which direct the data generation process. A training iteration for a cGAN consists of first training the discriminator to determine whether a given image is real or fake based on the input. In other words, is this image a real version of the doodle? Then we train the generator to create new images and feed it into the discriminator and use that output as a loss for the generator. For our discriminator, we use the simple CNN that you can see here. It consists of 3 convolutional layers with max pooling in between, followed by 2 fully connected layers before the final output of real or fake. For our generator, it was very similar to an autoencoder, with its most notable traits being the resonant blocks, which consists of 2 convolutional layers, each with a skip connection. Another key trait is that our loss function for the generator consists of adversarial loss along with the absolute mean error, also known as L1 loss, between the generated image and the target real image. Now I would like to pass it on to Naveed to showcase our results.
Thanks, Zeng. Now I will show some of the results of our model. Quantitatively, we can see that the loss and accuracy of both nets don't converge, and instead oscillate. This is expected for a GAN model, as the generator and discriminator are competing against each other. What's key to notice is that we want the generator loss to trend downwards, indicating that the generator is improving and is fooling the discriminator better. Looking at some results from the training set, we can see that the generator captures the shirt outlines very well, and can even pick up on small details within the shirt. The details can be slightly noisy, and this can be attributed to the images having a low resolution of 100 by 200 pixels. This low resolution was necessary to avoid extraordinarily long training times. If we move on to pants images, we can see that the generator can properly differentiate whether the doodle is a shirt or pant and color in details accordingly. These details are still pretty noisy though, for the same reasons as mentioned before. Moving on to testing results, these are inputs that the generator has never before seen. As we can see, the generator can still pick up outlines and textures very well, but as all the input doodles are non-colored, the generator has no idea of what the actual color is, so the generated images can have very similar colors. For pants, the generator chooses much darker colors due to its abundance in the training set. There is a proportionally larger number of jeans in the training set as well, and so the generator is pretty good at generating textures for them. To summarize the performance of the GAN, we found that it is very good at generating the general shape and texture of the clothing item, as well as recognizing simple patterns. However, it performs poorly when it comes to coloring in the items. The generator does not know what color to use since the input images are all black and white, and so it is biased towards whatever colors are most abundant in the training dataset. Overall, given the complexity of the problem and our data, we are very satisfied with what the model has produced. Now Gurmahar will show a demonstration of our GAN producing images from new input data.
Thanks, Naveed. I can now show you guys a quick demonstration on how our GAN works with new hand-drawn doodles. So here's a collab notebook with our final model loaded. We're going to feed our generator 5 newly drawn images. 3 of them are shirts, and 2 are trousers. I'll first show you what these inputs look like. So here are the doodle images that we created. What we now want to do is feed the doodles into the model and get the generated image. At this point, the model has never seen these doodles before. As you can see, the model generated an image relating to each doodle. I'll show you these in more detail on the next slide. So as you saw, the GAN generated somewhat realistic images. Details were blurred due to the low resolution of our inputs and outputs. But overall, the model was able to recognize what the clothing item was on the image, and it recreated and colored in details such as stripes and buttons on the shirts, as well as the belt line and textures on trousers. So here are some of our takeaways from designing and developing a GAN. While training, we found that the discriminator can learn too fast. This causes the generator to fall far behind instead of making the generator compete with the discriminator. We mitigated this by using smaller learning rates and adding another loss to the generator. In general, when training a model, we developed a couple helpful tips. Firstly, you never know when Google is going to time you out, so save your model state often. Secondly, it's a good idea to iterate and train over small datasets until you're confident in your model. This makes sure that you're not wasting your time with a model that's not satisfactory. You should save your results often too. When writing a report or looking back, you will want to analyze and reflect on them. So thank you for tuning into our presentation. We're now open to questions.